And I'm going to talk about how we support multiple Spark versions in our monorepo. Show of hands here, how many people are like JVM language developers? A few, okay. How many work with the Spark? Oh, none? No, okay, that's cool. I'll keep it general. So why is this like a topic for a talk? So for context, in our monorepo, we have about like 250 Scala Spark build targets. Some are common libraries. Some are like, like end applications. We started out supporting a single version of Spark, but there are new versions. Teams want to migrate to them. And there are some challenges building Spark applications, even with Maven, which is I think the most popular solution for Scala and Java Spark. So Java or Spark by default does not have any class loader isolation. So what this means is you ship your deploy artifact with all of your code to a Spark cluster. There's a runtime class path that has all of Spark's code and dependencies on it, and they live in the same namespace as your code and dependencies, which is fun. So Java, being a pretty big framework, has a lot of dependencies. Your app has a lot of dependencies. They may not always agree with each other. So a really common thing is Spark depends on super old versions of Jackson, which is a JSON parsing library, and Guava, which is like the library from Google that makes Java useful. When you import Spark from your code, that's fine. There's only one Spark. When Spark imports Jackson, and your application also includes Jackson, there are going to be issues potentially. This is so common that Spark even has like a check to make sure that the version of Jackson it's loading is the correct old one, and if it detects a new one, it will just crash and print an error message. So in Maven, the solution for this is an ugly hack called shading. So with shading, what you do is you take Java bytecode, and for the packages that are conflicting with your runtime, you relocate them. You move them to a different package. This doesn't work always. Like if you're using reflection, it's going to break horribly. But most of the time it's fine. So this is for example how shading Guava might look. So you take com.google.common and you rename it to shaded.com.google.common. And you want to do this both to the dependency and code that uses that dependency, because all the references need to be changed too. And we use a tool called JarJar Links for this, which incidentally Bazel also uses internally for Java tools. So the naive way of doing this is you can take your deploy jar and shade the whole dang thing. But this is slow. Deploy jars tend to be big, like maybe 50 to 100 megabytes. Takes time to shade the whole thing, and it's also like not cache friendly. If any of your dependency change the cache for this shading is going to be invalidated, and you have to do it again. So if you think about shading, it's really just like adding an extra action to your whole build graph. And what's a way to do that with Bazel? I think Ulf mentioned it. There's a feature called aspects that lets you just add extra actions to your build graph. This is a fun diagram taken from the Bazel docs. And it's pretty easy to just write a rule that just wraps Java library, for example, and returns a shaded version and just traverses the build graph for your target. And this isn't the full example, just kind of the skeleton. But basically, our aspect will add a new provider that just wraps Java info with a shaded version, and then just returns that new Java info at the end. Okay, so that's one problem solved. But we also have multiple Spark versions to deal with. And Bazel tends to work better if you follow a single version policy, and this totally breaks that, kind of by necessity. So, Spark has its own runtime environment. Our company has like a whole mess of Spark clusters with different versions. That is, a dependency closure that we just are not in control of. So it is not possible for us to force a single version policy here. And this is particularly, troublesome for common libraries, which you may want to include in different apps that run on different Spark versions. Rules JVM external, which is like the standard way of fetching Java dependencies with Bazel, lets you define multiple dependency closures. So that's like kind of that gets us somewhere. We can have multiple Maven installs for each of our Spark versions, which will give us an independent like dependency set for those. But how do we make this work with our common libraries? So like kind of the first order approach you could do is just fork all of the targets for your common libraries, have one version mapped to one Spark version. But this is kind of a pain, like, if we add a new Spark version, we have to like manually like, add these, update these targets. This is going to break IntelliJ in a few different ways. Yeah, so not great. But what's the tool that we always reach for in computer science? Indirection. So Bazel also lets you add custom flags, and these flags can change build targets. So that's great. Now we can have like this abstracted Spark target that will pick the right version based on a flag, and as long as everything uses that, then you're good. But I mean, you also always talk like, why would you want to add another flag to Bazel? There's already like 600. So, and this is difficult to work with, to use with CI. If you have like, you need to somehow like add metadata to all of your targets. Let's say like which, like what CI configuration to use. I mean, let's just, we can do better. It also breaks Bazel query, but that's, just an aside. So there's another cool feature in Bazel called transitions. And this lets you apply flags within your build graph. It happens, I don't think this is the like, anticipated expected use case. I think it's for building like multi-arch binaries, but turns out we can use it here too. The only problem is you cannot, you have to apply it to rules that you maintain. Like you can't apply it to existing rules for good reason. Like you can, explode the build graph pretty easily with transitions. So, and this is just like a quick example of like what what a transition definition looks like. It just returns a flag and the value you want to set it to. So thankfully, rule Scala is nice and customizable, and it actually provides plumbing to let you define custom versions of all of its rules. So we can just define, use their function make Scala library to define our own cool version with transitions. So here, I'm defining a new Scala library custom rule called Spark Scala library that will transition all of its dependencies to the Spark version that you specify. And the final piece is deploy ends. So this is like a feature of the Java binary rule that lets you specify a Java binary that represents your runtime environment. So here we just want to define these for each of our Spark versions, and these will all get like stripped out of our deploy jar because they already exist at runtime, so we don't need to build them into the jar. So putting it all together, we can just define a macro that just strings these three pieces together. It's like a simple solution for users, and most of the time it just works. All right, that's it.